Hi there, I'm Hao. This is just another video of me solving randomly code problem. So we have the n queen problem. So we have an input n, which represent the number of queens we need to put on the board in such a way that they won't attack each other. So a queen can attack vertically, right? Vertically, up and down, or horizontally, and also diagonally, right? Okay. So we can try the backtracking. We can try backtracking, but with the brute force approach, right? Which means we're gonna try to place the queen in every single square and check to see if it works, right? If it is being attacked by all the queen, right? Keep going like this until we find a spot, right? That is safe, like this, right? But that will give us like the time complexity of, because we need to run the backtracking for every single um square, right? So like n square, right? And so we need to run a backtracking for n square elements, right? Because if n is 4, then the board gonna be 4 by 4, which is like 16 tile, right? 16 square, right? And for the backtracking, so which means we have, what is the height? The height will be 4, right? Which is n. Because we will stop where we have successfully placed the 4 queen on the board, right? So this is very slow. It will give us the O of n to the 2n, right? But we can try something different. We are using an optimization, right? So we know that if we put the queen on the first row, then we know that the the second queen, for example, cannot be placed on the same row, right? So every time we place a queen on one row, we can increment onto uh, the next row, right? So if we place a queen, uh, we're gonna have like one less queen to consider, right? Which is like 4 times 3 times 2 and times 1, which give us the time complexity of 4 factorial, right? Or you can think about it in another way. So let's say you look at the output here, it gives us like an array of the board, right? So we can do like 1, 2, 3, 4, right? Which means we can place a queen like this, right? 1, 2, 3, 4. Right? One is like the first tile in the first row, 2 in the second tile in the second row, so on and so forth. And we can do 1, 2, 4, 3, 1, 3, 4, 2, 1, 3, 2, 4, and 1, 4, 2, 3, and 1, 4, 3, 2, right? So we can have like 6 different combination by simply starting at 1, right? But we can also start like at the second tile or the third or the fourth, right? So we have 4 options here. So we need to multiply by 4, which is 24, right? And it is the same at 4 factorial would equal to 4 times 3 times 2 times 1, which is 12, 24, right? So this would be better than uh, n to the 2n, right? Because we don't need to run the backtracking on every single uh, tile. Okay, so let's look at an example here. I can like quickly walk through it. 1, 2, 3, 1, 2, 1, 2, 3. Okay, let me change the color here. But let's say I can start the row, right? Can be start 0, right? Like the index, right? 0, right? So I can increment to the next row whenever I place a, a queen. That's called as Q, right? And on the next row, I can check this tile, right? It's not safe because the queen can attack vertically. This way also is not safe because the queen can attack uh, diagonally, right? But I can place it here, right? And now I can, as soon as I place the queen, I can go to the next row because I know I cannot place 2 queens in the same row. I check this where it's not safe, right? this square is not safe because it can be attacked. Just here, not safe, not safe. So in that case, right, I just return backup, right? Uh, pop it off or set it back to a dot, right, for an empty square and move on to try the next square, right? And I can go to the next row. I check this tile, not safe, but this tile is safe, right? So I can move on to the next row, 3, okay? So this is not safe, this is not okay, this is not okay, this is also not okay, right? So I return back up, right? And try the next square. But this is not safe, right? Because it can be attacked. Here is also not safe, so I return back up again, right? To here, right? But at this tile is already the last tile in a row, right? So in that case, I just gonna return back up again, right? Q here, and then continue to try, right? So now these 3 are not safe, right? So I place the queen here. Right? I can go to the next tile. This is safe, so I place it here. I move on to the next one, right? Here is not safe, right? So I can place it here. So right now, because the number of queens remaining is 0, or because we have reached the end of uh the row, right? Which is the last row, right? So when row is equal to 4, right? So we are starting at 0, right? We go to n minus 1, right? And if we have successfully placed the last queen on the last row, right? And then the next recursion call will be equal to n, right? 4. So it is our base case here. Then we can set the board into our resulting array. So if you look here, this is 2, right? So 2, uh, 2, 4, 1, and 3, right? Corresponding with the position of the queen, right? And we also have 2, 4, 1, 3 here in our output, right? So that is one of the solution. And we just need to keep going, right? Until we have tried every single tile on the first row. Okay, so let's post this up. All right, so first of all, we need our result array, right? And and by the way, the board here will be a 2D array, right? Because it's 4 by 4 or n by n. When we want to set the board, we have to make a copy, right? Or we need to iterate over the current board, and then join each row to become like a string like this, right? So each sub array here will be a subboard. It's one of our answer. So we can have our result, and we can return at the end, right? We also need our board, right? We can start out by creating a board of n by n size, and then fill them up with the dot, right? So array from, and then have a length of n, right? And it will be subarray will be also array dot from, right? Array dot from, and then also the same line, right? N by n, length of n, and then comma. We're gonna fill them up with a dot, right? Okay. So we can console log the board to see if it is correct. Run. And yes, so we have an initial board uh, with an empty space, right? Which is the dot, and we can um, place the queen in the empty space. Okay. And then we need to run the backtracking function. right? Style at index 0, which is the first row, right? So backtrack equal to row, right? If the row is equal to n, which means we reach our base case, right? Remember, we were able to place the last queen onto the last row, right? Because we are starting at 0, so 0, 1, 2, 3. But if we get to 4, which is equal to n, which means the board is complete, right? So in that case, we can add the board to our result. And how can we do that? We can do result of push, right? The empty array first, right? And we can iterate through the board for each right row. And we can do result at the last index, right? The array which the array we just push here, right? Which is the last index, the result dot length minus 1, and we want to push in the row dot join by an empty string. Okay, and then we want to return. Okay, so this is our base case. So for our recursive step, right, we want to try every single tile. So we want to try every single column for each row, right? We can try every single column. So we can do backtrack or something, and then right the board and the row, the column equal to the dot, right? So after we backtrack, we want to set it back to an empty space, right? And try the next column. And here we can set it equal to the Q, right? And when we run the backtrack, we want to go to the next row, right? So when we place a queen, we want to go to the next row immediately. When we return back, right? If that doesn't work out, or if it worked out, we make it become an empty space again, and we retry the next column, right? The row, what is the row? The row will be our current row, right? We try every column on the current row, okay? And we only want to try this column if and only if the column we are about to play is valid, right? So if it is valid, right, we will try that. So we have to create a is valid function here. We can pass in the row and the column, right? So we have to make sure that it is valid and the spot is empty, right? So we don't have to check for the empty position because we know that as we iterate through each column in the row, right, it will be empty because we start out at an empty board and we always reset the tile back to an empty space before we try the next column, right? So we only need to check if it is valid. So it is valid means the queen, if the queen was to play in this row and column, in this position, then it is safe from other queen, right? It's not gonna be attacked vertically, horizontally, or diagonally. So we have how many direction? We have so if the queen is here, right? The queen. Let me change color here. Queen is here. We're gonna have one direction, right? Up, down, left, right, right? Also diagonally. So we have like eight direction. Okay. So we have to create a type of function is valid between the row and the column. And so we need a direction array. So we have like eight direction, right? So 0, 1, right? 0, -1, 1, 0, right? And then -1, 0, right? -1, -1, -1, 1. and then 1, -1, and then 1, 1, right? So this is our A direction. So the strategy is that we keep moving in one direction until we are out of bound, right? And if at any point we found a queen, which means it is not safe, right? Not valid, so we can return false. So we can keep going left, right? If we see a queen, which means it's not valid, and return false. Okay, so line I plus plus, right? So dx and dy, right, which is the amount that we will increment, equal to direction at I, right? We have to check the new row equal to row, and a new column equal to column, right? And y, the new row is greater than or equal to 0, which means it is inbound. New row is less than n, and then new column less than n. Oops, a typo here. Which means we can keep going, right? And we can check if the board has this new row and new column, right? Is equal to the queen, right? That's why it is not set, so we return false. Right, and we have to keep incrementing the new row and the new column by dx and dy. Right, so we keep moving in one direction until we are out of bound or until we found a queen. If everything is good, right, we don't find any queen, okay, we can return true at the end. Right, so that's pretty much it. Let's give it a try. Okay. Why do we have so many output here? So let's check our is valid function again. So we have row and column, we have a direction, 0, 1, 0, -1, 1, 0, -1, 0, -1, -1, -1, 1, 1 minus 1, and 1, 1. Okay, so we iterate to each direction. We have our new row and new column set equal to the current row and column. And then why is it? It is inbound. We will keep going, right? By incrementing dx and dy. And then if we see the queen, we will return false. Oh, new row, new column. Okay. So let's start again. There's a typo there. Submit. It did work. So thank you for watching. Oh, and yeah, by the way, our space complexity would just be O of n squared, right? Because we need to the board here to store our board, right? N by n board, right? So thank you for watching.